Is anybody here that didn't see Steve Connect's discussion this morning? Okay, so everybody here saw his... Okay, so I'm not going to give you his normal biography in that case. I've known Steve for quite a while, and I want to talk with you a little bit about some of Steve's philosophy. He and I met when I was doing my master's and he was doing his PhD up in southeastern Idaho, and he really taught me a bit of philosophy that I still take with me today, and it was actually when we did get tired of sagebrush when we went out fishing on the weekends. And this is where Steve imparted a philosophy to me. When we'd be fishing and a nasty bank of clouds would build, one of those scattered afternoon thunder showers would come right at us, he'd see this bank of clouds approaching and he'd say, "It'll go around us." And no matter how big it was, no matter what direction, no matter what speed, if it was coming right at us, Steve would say, "It'll go around us." So we'd keep fishing. And as those clouds opened up and poured buckets of rain over our heads, I realized that Steve was really more of a philosopher than a prophet, at least in terms of weather. And I think in terms of shrub steppe ecology and wildlife, as you heard this morning, some of his predictions, I think that he is definitely much more prophetic as well as philosophical when it comes to shrub steppe ecology. And what Steve is going to discuss with us this afternoon is shrub steppe, sagebrush steppe restoration and shrub steppe obligate birds.
Well, thank you, Frank. This is going to be more philosophy, like I started into this morning, except this afternoon we get to add the birds, which to me is really an interesting component and an incredibly challenging one, because it requires that we know something about how birds view habitats and how they use habitats. And so we get into the issue of what is habitat selection. And our idea of habitat selection has changed a lot, over, say, when we first started doing some of these studies, and it's changed also in relationship to the tools we've had available to start measuring habitat selection. And I think of some of the earlier studies where we went out and we did a typical bird was here or an animal was here, and so we measured vegetation at that point. We took a couple other random points and we got some idea of what birds really were using at the time relative to what might be available. But it wasn't until we had GIS and some of these spatial coverages and the ability to map vegetation in some of the detail we can, that we're able to look at the different scales at which a species selects habitats. That makes it incredibly more challenging than just being able to say, what they really like is more sagebrush or something like that, a simple explanation. And I'll give you an example from the sage-grouse world. Up until some of Cam's analysis looking at more of the landscape features, the basic conclusion could be distilled down to, if you don't have sagebrush, you won't have sage-grouse. But the flip side of that isn't necessarily true. If you have sagebrush, you still may not have sage-grouse. And so why is it? And that's the challenging part of it. Is there something that we aren't measuring? Is there some different way, or the way we're measuring things that are wrong? What metrics are we using? And are we able to match the things that we're measuring then to the ways in which a species selects its habitat and uses habitat? And I think we've got to start on that for some of these passerine birds. I'm not sure that, I think we have a long ways to go in terms of the sage-grouse, which is, again, a lot more complicated species, largely because of the much larger ranges that they have that encompass many different spatial scales in which habitat is arranged. And so, ultimately, what I'm going to get in this talk today is, can we manage for sage-grouse and expect to benefit the suite of other sagebrush birds that live in these habitats? And to do that, then we need to know something about how sage-grouse use habitats. We need to know how all of these other birds use habitats. The short answer is yes, I think sage-grouse can be a good umbrella species. So that's the conclusion of my talk, and you can sleep until we get to the end now. But there's a huge but in that, which is that the habitats that sage-grouse select are incredibly variable. And if we only focus on those narrow means or narrow points listed in some guideline or some rules or some kind of prescription, we narrow that umbrella under which sage-grouse habitats we manage for, and the other species that will benefit from this management for sage-grouse are going to be fewer and fewer, and the amount of benefit that they receive will be much less. So, to do that, though, we have to understand habitat. And what I want to do is first start out in terms of the way I describe habitat, some of the issues in the sagebrush system. Look at the way in which different kind of actions, land use actions, may influence habitat in the way that, like I say, I describe it in terms of landscape and habitat components. Then we'll get into how the different shrub steppe bird species select habitats. And ultimately then we'll add sage-grouse on top of that. So this is a sage-grouse biome, actually. Thank you. The sage-grouse biome, we have said the sagebrush biome, but sagebrush does range well beyond this map, but it's based on the historic distribution of sage-grouse and buffered by a little bit to include some of the other external processes that might influence things on the edge. And as we've noted in numerous talks, that this habitat, sagebrush, is a highly variable habitat, and that makes it difficult for restoration, makes it difficult for understanding species responses because there is no single ideal habitat or no single set prescription that we can put in place. But it's highly variable, and across these gradients, precipitation, elevation, and soils are the primary factors that influence the different kinds of sagebrush species and habitats in proportions that are in a place. Disturbance is important. And that's something we tend to forget in terms of restoration, is that disturbance has always been a part of these systems. The frequency with which disturbance occurs and the spatial scale at which disturbance occurs is not out of whack, and that's what's causing the problem. But we have to recognize that many of these systems operated with a disturbance component, and we cannot eliminate that from ultimately what we're trying to achieve. And the other conclusion is that most systems are altered. Or if they aren't altered at some extent, as Cam pointed out, most of these systems are within a very short distance, ecologically speaking, of some kind of a landform or land use feature that we have imposed upon the system. To some of the issues, there's not just sage-grouse, which gets all the attention. There's about 350 wildlife species that depend on sagebrush for all or part of their annual or life cycle. There have been a number of different petitions to list different species, the sharp-tailed grouse, pygmy rabbits, and of course the greater sage-grouse, Gunnison sage-grouse. The invasive plant species, these altered fire and disturbance regimes in the Great Basin, as I think it was Wendell pointed out this morning, is one of the top 3 most endangered ecosystems in North America. So clearly we're in need of a poster person for sagebrush management and restoration. And this would be my vote for a poster person. It's the brewer's sparrow. Population across the range is declining approximately 3.2%. I have in this slide, but it's 3.4 in this slide. I didn't make the change, but who knows what they'll be declining at by the end of this talk. But obviously the brewer's sparrow isn't going to do it. So the poster person then is the greater sage-grouse, declining at about 2% a year over the long term from, I think, 1965 to present. And when you look at different windows of that population decline, some of it is a little bit faster, 3.5% a year. More recently, a fairly narrow or fairly light 0.4%, I think, rate of decline over the last 20 years. So somewhat of a stability factor in the last 20 years, but it's also been a series of fluctuations increasingly downward, so we don't know where we're at in this trend. But there are a lot of other bird species besides just the brewer's sparrow and the greater sage-grouse that live in this system, and here are just some of them. And noting the rates of change, by and large, grassland and shrubland species as a group are declining at much faster rates than any other species groups of birds in North America. And a lot of this, again, is not only shrublands, but related to the loss of grasslands in the Midwest as well. You can see some pretty significant declines. So if we're going to start restoring habitats, what do we do? Are they all going to benefit the same if we do some kind of a restoration prescription? And so one of the things we've looked at is how these species use habitats, put those on a gradient, and then relate that to sage-grouse use of habitats. And so what I'm going to talk about today is then these other shrub steppe birds and how they relate to habitats. The first thing we need to do then is if they're going to respond to habitats, how do we describe habitats in a way that is meaningful to the birds and in a way that's meaningful to the way that we can measure it? And ultimately, will managing for sage-grouse benefit these other species? The habitat characteristics is the way we define them. Like I say, in a typical rangeland sense, we often refer to a percent cover, and that's determined by a line intercept, and so we might have 15 to 20% sagebrush habitat. What's often omitted out of that is the spatial component. And so if we want to manage for sage-grouse or any other species, and the prescription in the rangeland guidelines is for 20% sagebrush cover, the question I ask is, how large a patch area does that need to be? Does it have to be 1 kilometer? Does it have to be a half hectare? Does it have to be 100 square kilometers that we have that kind of a land cover or percent cover value over that area? So that's the difference oftentimes in the language that we speak between the rangeland and the spatial ecologists in terms of how we measure habitats and what's important to a species. The habitat components, the way I measure them are typically the composition, the quantity of what's out there, and the configuration of that habitat. The composition is simply what's there. You know, what species, whether it's basin big sagebrush, Wyoming big sagebrush, silver sage, or something like that. That tells you a lot about what that system is like, whether it's silver sagebrush in a more moist condition than it would be with a Wyomingensis type of habitat. The quantity tells you how much of that is there, and the configuration has other components. The configuration then is how that habitat is arranged. And that becomes important when we talk about, again, what is a mosaic? Is it the Dalmatian or is it the Holstein? And what that means is you can have a landscape that is 50% sagebrush and 50% grassland, but that can be arranged in many different ways. You can have all 50% sagebrush on one side, you can have all 50% grassland on the other. That has a very different type of response in terms of wildlife than if you make it more of a checkerboard. And so you can divide that, you can do it into quarters, you can do it into sixteenths or whatever. But that's the analogy between whether you go to, I've heard it as a white horse going to an Appaloosa to a black horse or something like that. But you get the idea that there's all these gradients. How you arrange that habitat is important because that also then impacts the kind of edge that you have, which is important for the dynamics not only of the habitat, but it makes a difference to birds in terms of things that are influencing their distribution. Predators may respond to edges, things like that. So being an area-sensitive or an edge-sensitive species that is influenced by the configuration of that habitat. So we have these three quantities or three characteristics of landscapes. There's the quantity, the composition, and the configuration. Someone suggested to me that there was an aesthetic quality as well, but I only deal in numbers and I don't know how to measure aesthetics, so I just stick with the three. So then if we go through the primary issues that influence sagebrush habitats and start thinking about how that landscape is arranged. Look at the edge, for instance, between an agricultural landscape and a series of sagebrush islands within an agricultural matrix. Look at this system that's largely dominated by cheatgrass, a much softer edge within the existing sagebrush patches or plants, but again, a very different kind of disturbance that's going to influence it. One of the other primary issues then is livestock grazing, and that's the more difficult one to measure because livestock grazing tends to act as a pulse rather than something that actually physically creates edges and hard differences in habitat. So the issue of livestock grazing is not one that's easily resolved and is probably going to be debated for quite some time, just simply because of the way livestock grazing influences habitats relative to these other kind of primary issues. And energy, of course, then also a factor in the way that it influences habitats by punching in wells and having infrastructure that have both an immediate effect as well as a larger scale effect. Each of these different land uses and changes then imposes a signature on the habitat in terms of these quantity, configuration, and composition. And if we measure those kind of features over the sage-grouse biome, we can map out places where fragmentation in the reds and yellows, apologies to anyone who's colorblind, we can map out the areas where fragmentation dominates the landscape as opposed to other areas where the dominant feature is the sagebrush in the landscape. So we get these trade-offs and different signatures of landscapes. And indeed, as we go around the whole biome, then we see the different kinds of results that come from not only these gradients of habitat and land use issues, but also historical features and factors. We talked about state and transition models, and this is my idea of a state and transition model. And basically it incorporates space. You can remove one shrub out of a patch and nobody's probably going to notice. If you remove a bunch of shrubs, still none of the birds are probably going to notice, but you reach a point then where if you remove a whole bunch of them, you slip into this system right here where it could go either way. And with cheatgrass or something like that, you reach this threshold where all of a sudden you spiral out of control and you end up in a situation like this where you cannot get back to this original distribution without a massive amount of energy. And this is just basically a state and transition model that Dave Pike showed, but with a spatial scale and a disturbance quality input into it. The fun part is that birds then, if you impose the way they select habitats on this, you start to see the way these different disturbance features then may result in a response by the bird species. In that, passerine birds tend to select habitats at a much finer resolution and scale compared to sage-grouse. And so my thinking is that the smaller shrubland birds are a much better indicator of some of the small-scale changes in sagebrush habitats, but that sage-grouse with much larger home ranges can absorb more of the smaller-scale changes until it reaches a threshold at which point then the sage-grouse also go. So whereas we see relatively linear declines in the shrub steppe birds, sage-grouse show these fluctuations in response to the habitat as it changes. And again, just put this in the context of the Powder River Basin, and you can see that there's going to be local scale effects, landscape effects, and this is what birds are responding to. What we've done is, I showed this earlier this morning, and it's a trade-off. Different scales are important. Not only the shrub density of what's there, but the patch size as well. It just shows the importance that one single metric doesn't really capture the way in which birds select habitats. In fact, it's a gradient. And if we put all these birds on this gradient, which is this axis right here, as you go from increasing grassland and disturbance on this end to increasing shrub cover and increasing patch size, you go through this different increase in different optimum conditions for birds. And so you have, as you put changes in your habitat, whether restoration or disturbance, along that gradient, your bird community shifts as one species benefits and another doesn't. I've always said the beauty of management is that something's going to benefit and something's going to lose. You always have gainers and you always have losers, no matter what you do. It's just a matter of where you are in the axis. So one of the nice things about research is that you get to complicate matters. And so you can put these axes on different gradients and basically look at the way habitats are going to shift along any of these gradients and look at how the change in the bird community is going to be along those gradients. So now, we can't do management prescriptions for every single species that's out there. Is managing for sage-grouse going to be enough where some of the species on the outer edge is going to get wet? We went out and we looked at, in terms of series of sites as well as GIS analyses, where birds were found. We did surveys not only for all the different shrub steppe birds, but also for greater sage-grouse. And we looked at whether or not that portion of the gradient that was encompassed by sage-grouse, how that influenced or how that was also reflected in the part of the gradient along the bottom here that was shared by different species. So along the bottom you have each of the different species fading in and out relative to their optimum habitat conditions, and you have sage-grouse. Conclusion is that sage grouse do overlap almost all of the species that are going to use sage steppe habitats, with the exception of some of these others, the grassland birds, grasshopper sparrow, and the savanna sparrow. But again, sage grouse as an umbrella species could be quite an effective species. The problem comes in if we start narrowing the window, the range of habitat conditions that sage grouse use, because then essentially we narrow this part of that window of overlap, the umbrella, if you will, and you start cutting off more and more of the species. So it's important to manage for the variability. That variability includes not only some of the newer reestablished sagebrush areas, but also the old growth, sometimes called decadent or degraded, but those areas are just as important in this gradient as are some of the other habitat types. It's that variability that's important. So just to conclude then, and tie this together between the birds, the sage grouse, and the habitats, we can describe habitats by composition, configuration, but also by the quantity. And I think we're getting closer to being able to describe habitats from the way a species actually views that habitat. The bird distribution and abundance is a function of these landscape characteristics as well as the characteristics within the shrub patch itself. Managing for sage grouse will benefit most species, but we need to manage for that full range of habitat conditions if we're going to have the maximum amount of benefit. So again, I'd like to conclude with some acknowledgments then. The people, Matthias Loy, Kurt Fesselmeyer, Kara Meinke, who I work with at the U.S. Geological Survey. Bureau of Land Management has funded a lot of my work on species and habitat selections. And my longtime colleagues, John Rotenberry and Jack Conley. Thank you. Yeah, that would be St. Conley. I never lose an opportunity to make a comment about my friend Jack. So, do you have any time for questions?
Yes.
Okay.
We do have time for some questions. Yes, Ken.
It's often said you need the full range of habitat along gradient. Have you looked at which portions tend to be in abundance and which ones along the gradient tend to be lacking?
The question was if in terms of the gradients we looked at across the biome, which ones would be in different abundance. And no, I don't know that we've done that. And I'm not always sure how we would do that. And the reason being is that some of this, the way you might describe it in terms of the age of stands, might be possible for some of the homogeneous landscapes, but on the other hand, many of those seemingly homogeneous habitats also have different age sagebrush plants within them in different stages of regeneration. So I don't know that we've done that, or I don't know how we would do it. In terms of the configurations of habitat, what we would have to do is take some of those coefficients that we developed for the different the ordination axes and see if we could map that and look at the proportions of that, and that hasn't been done. Some of the issue there is the variables that we use to measure those habitat characteristics in making those ordination graphics or gradients are not variables that we also have in a GIS coverage over a broad scale. And that becomes, when you get into spatial modeling, if you don't have a consistent data set to cover a biome or a landscape, you end up using either surrogate variables or not using that variable at all, and you lose a lot of the potential information. So those are the reasons why we haven't, and no, we haven't.
Other questions?
Yeah,
yes.
On your configuration slide you have up there, one of the categories was matrix. Could you expand a little bit more on the matrix, or how would you describe that matrix?
This one?
Yeah.
Configuration is a way to describe this mosaic. And the mosaic then has a number of different features based on differences of the patches within that mosaic. And so an edge, for instance, right here, can be a hard edge if you have, for instance, an agriculture or a burn right next to a shrubland. It can be more of a soft edge if you go from a grassland next to a sagebrush grass mix and then grade into more of a sagebrush patch. And so that edge then is one component in a GIS that's relatively easy to measure in terms of, you have your different polygons and you measure the amount of edge in the polygon. The patch size then is just simply the area within that homogeneous polygon. And that polygon can mean not only shrub cover, it can mean other characteristics that are homogeneous within that patch size. You define it, usually we define it as a dominant vegetation cover. And so you have this edge, the patch size. There's also a way to measure texture, which captures then the black and whiteness of that matrix, whether it's a series of shades of gray or whether it's a very black and white checkerboard. And those also have an influence then on a way in which a species responds to that habitat. So it's not only a function of the soft or the hard edge, but also the difference in habitats that are next to each other. There's one other, a contagion that you may have heard, which is a way of measuring how patches are distributed, like patches are distributed throughout the landscape. And do they tend to be grouped together in a very small area, or are they widely dispersed throughout that landscape?
So the matrix is more of like past management that influences vegetation?
The matrix could include past management, but I tend to think of it as the existing set of habitat patches that are there right now. So if you're able to fly above this area and look down, what do you see? It's this mosaic or matrix of different habitat components that are adjacent to each other. And you can look at that. These are really dimensionless in that you can apply these characteristics to a very small unit of land, characterize individual shrubland plants, or you can apply it to basically a biome and look at similar characteristics. It's kind of a unifying descriptive metric that you can use, but you need to define which scale and which resolution you're looking at. Okay?
Time for one more question? I'll ask if you guys know. Okay, you mentioned using sage-grouse as an umbrella species, and that sometimes you can shrink the umbrella depending on your management. And it seems like now we're doing that with a lot of removal of decadent sagebrush, managing for sage-grouse fruit-bearing habitat. How's that going to affect this wide suite of passerines, in your opinion?
I don't know long term, because I'm not sure what it will come back as. In the short term, though, as you shift that mosaic away from fairly large, continuous patches of sagebrush, you lose the ability to support a lot of the area-sensitive species like sage sparrows, sage thrashers. And so the more of that open land you create, the fewer of the shrubland obligate species are going to be within that habitat, within that landscape. And we actually looked at like within a kilometer squared in terms of, and Matt Vanderhagen in Washington has looked at over a 5 kilometer squared radius out from the point. So I mean, it's the percent of the land cover within that large an area that is influencing initially where these birds select a breeding range.
Is that then why it's better to do the Dalmatian approach, the smaller scale?
That's exactly why, yes. You could remove X% of sagebrush, but if you keep those patches interspersed within the landscape, you have a much different effect in terms of how the birds are going to respond and then being there, as opposed to taking a big block of 50% of a landscape and doing your treatment over that large an area.
Okay. Thank you, Steve.